I got a couple kind of practical things to mention here using one of these later Monarch 10EEs. And that's when you're doing finish work on alloys, and that's what you work with this machine. You work alloys. You don't run hot rolled steel through this thing. You make tools and shafts and things. Well, to get the really close tolerance on those hard materials and alloys, the best path to follow is that laid out by Romicron Corporation in regards to the use of their boring head, and follow those parameters to get that plus or minus 80 millionths. So, but there's some physical things you have to take in consideration. And when I'm working alloys like that, at 2 inches, a little bigger, when I take finish cuts, I'm running this machine almost full blast. Yeah, this machine's real happy running at 3,800 RPM. It seems like the last 200 to 4,000. Yeah, I don't know, it just kind of sounds like a turbine or something. But, these things are all individual. They're made one at a time, custom ordered. So there's going to be a little bit of variation, but 3,800 RPM, this thing runs really, really good. And any vibration that creeps in when you're doing these finish cuts is going to affect the work. And usually what happens is the part ends up bigger on the end. So one thing of critical importance is the fit of the back of the chuck, there we go, to that spindle nose. And it's got to be snug, but not too tight, and not loose. And another thing is, when you're running up that high speed, the chuck has to be balanced. And you can see here, this chuck here has been dynamically balanced on a shank machine. I had that done by a company I do a little work for over the Hanford area. So this chuck has been reworked. It's 5 3/8 inch in diameter, and it pretty happily runs up to 4,000 RPMs. Now, a 3-jaw or any squirrel chuck, normal anyway, is going to have problems at high speeds. They just don't work very well running over 3,000 RPM. The worst chuck I have for running fast is that 6-jaw chuck over there on the manufacturing lathe. That thing's dreadful. It's actually, I don't think it's safe to run it over 2,500 RPMs because it'll let loose of a bushing, for example, at that speed. So I use that for thin wall stuff, but for high precision work, for doing a shaft or something like that, the 4-jaw just can't be beat. It can't. And I have this one and one a little bit smaller made by Skinner. This one's made by Cushman. So I thought I'd show you that part of it. Then another thing, if you're going to try to make money with this thing, you got to be able to put out consistent work. It's got to be consistent. You can't take a $300 X-ray piece of alloy material and goof it up. So one of the things you got to do is you got to figure out what you're going to do with the tools, your cutting tools. Now, you can buy all kinds of inserts. This is a tool and cutter grinder here, an old Cincinnati. It is a great old machine. But for finished tools, I make them, mostly. There's some boring bores right there. You can see I forged this 1/2-inch steel. And I brazed carbide blanks that are laying there. You can see that. Then I can sharpen these boring bores directly in the workhead here. This is a powered workhead. Of course, you don't have it going when you're sharpening that stuff, you lock it. But there's a boring bar hanging out of it, and you can see I can sharpen the different angles on it by moving the head around. Then ultimately, you can put it in this V-block here, a little stair V-block with a tail on it. Put that in a collet in the workhead there. Further work a boring bore. For cutting tools, for finish tools, I use brazed carbide, just standard brazed carbide bits, but I really prefer the brand called Micro 100. It's a general purpose carbide, a high quality. But back on these boring bars I make here for alloys, that's just C2 carbide. You don't want hard carbide when you're working hard alloys at high speed on the jig bore or this Monarch 10EE. There's the workhead there. There's the spindle head there with a diamond cup wheel in it. And this thing could be twisted in all directions. You can do anything you want with it, cut radiuses, just lots of stuff. But this tool is very central to what I'm doing. You don't absolutely have to have it, but I kind of think you do if you want to do consistent commercial work. All right. So, I'll look back at this thing. So we're going to be running this thing very, very fast. And, in a few videos or so, maybe take a test cut and demonstrate some things. But I want to show just how this thing's supposed to work. There's a lot of these machines around, but if you're thinking about buying one or something, how do you know if it's working properly? And that's one of the things that the video here is going to show, is one of these machines that works properly. Okay, with that, I'm going to try to get that module thing done. And there we go.